My role as fish ecologist is to conduct local projects based around the ecology of freshwater fish native to the Murray system and also pest fish, including some work on conservation of threatened species. Today we're at a wetland system that we call the Butler's Creek system near Mildura. It's a wetland system of the Murray River. What we call off-channel habitats are these creeks and wetlands which are part of the Murray River system. They're important to native fish which have adapted through time to use these systems as important nursery habitats or foraging habitats, sometimes as a refuge during drought or periods of low flow. So these off-channel systems provide an alternative to the flowing river channel of the Murray itself, which can be particularly useful to small, young stages of lots of native fish that prefer the low flow environment and maybe the warmer waters of an off-channel system. Historically, these systems were what we call ephemeral. They would regularly go through a drying phase or at least a lowering of water level before the next flood came through to refill them. With the installation of the locks and weirs, we get a more stable water level, and so some of these systems tend to remain more permanently full, whilst others located below weirs are more likely to dry out. And that's had a particularly negative impact on many of the native fish species from the Murray system. The more permanent, stable water level has been really beneficial to some pest species including carp and gambusia, or the mosquito fish, which were introduced after Europeans came to Australia. And these pest species love the stable water level and the warm, shallow areas such as we're looking at now with Butler's Creek. So in effect, river regulation, whilst having a negative impact on native fish, has been beneficial to some of those pest species. Natural resource managers such as the Mallee Catchment Management Authority in this case are conducting programs to try and return a more natural water level cycle to these billabongs and creeks, and they do that predominantly through installing regulators on off-channel systems such as this that allow them to stop water flow to the wetland and therefore let it dry out for a period, or at least draw down through evaporative processes. It also allows them to open those gates or regulators next time there is water available to refill these systems, in a sense turn some sort of wet-dry cycle back to the billabong or the creek in question. These are pretty low in water level, which is akin to what traditionally happened during a dry year or a drought. The next step will be to let water return to the system. Now, what we're interested in as fish ecologists is the behavioural response of native and pest fish when that water re-enters the system. We want to know about the lateral movement, or the movement of fish between the river habitat and these off-channel billabong habitats. And the way we do that is generally we stick big nets across the channel that connects these systems, and then when the water enters or drains from these systems, we catch all the fish moving in either direction to identify which species are preferring to enter a wetland as it fills or exit, and same deal when the wetland dries up. So the netting surveys we've done are quite useful. We can leave nets out overnight for multiple days, and we can get a feel for which species are preferring to move into or against flow when managers turn taps or regulators on and off. It's quite an expensive process, and it involves a lot of labour and a lot of time. We're starting to explore some new technology which includes acoustic tracking of fish. So this is essentially planting a small device in the body cavity of fish, which allows us to track their movement past receivers which we'll set up strategically throughout this system. So today, in conjunction with the netting program that we intend to do, we're going the next step, and we're going to put some of these tracking devices in some fish within the Butler's Creek system to get a handle on how good the technology is in terms of studying fish behaviour. You ready? Yep. So once we capture the fish, the individuals we intend to put the tracking device inside, we'll take them behind me here. We've got our station set up. We anaesthetise them gently using a veterinary grade anaesthetic, which knocks them out. Once they're unconscious, we put them into a custom made surgery table where we can keep water flowing through their gills, keep the fish in reasonably good condition, while we quickly implant through a centimetre long cut in their abdomen. We put the device inside, sew them up, and then we let them recover in a recovery well.
So this is the acoustic tracking device that is implanted into the fish, and once we've got this guy in, we put in a dart tag, and this has got who we are, Murray-Darling Freshwater Research Centre, our phone number and a reward. So if the fish is found by anglers, we can recover our gear. and not lose the data. After we've implanted the fish with the tracking device and the dart tag, we recover him in the holding tanks over here. Once the fish is fully recovered, we release it back into the wild.
From that point, the next step is we situate our listening stations or the receivers at strategic points throughout the Butlers Creek system, and once the system fills with water, we'll actually be able to tell which areas of the creek the fish we have tagged will move to or between.